All right, so we are in chapter 1. We will finish that and then go to chapter 2. All right, so talked about experiments, uh, scientific method, conservation of mass, mass of reactants equals mass of products, physical states, color, boiling point, melting point, chemical um, states, chemical constitution, whether it is doing a chemical reaction or simply changing its physical state of matter. Measurements and sig figs. So measurements, number with the unit, and sig figs. You have your two rules. When you're doing multiplication division, it is all about sig figs. When it is addition subtraction, it is all about the decimal places. SI units, make sure you know the SI units for the different measurements, and we'll go through those. And then we went through some derived units. All right, so we're still doing 6, 7, and 8, so we will go through those. All right, so rounding, we went through that a little bit. Again, if the digit is 5 or greater, then it's going to go up 1. If it is less than 5, it remains the same. So here's the example. If you have your 1.2151 and you want 3 sig figs, remember what 3 sig figs means. It means that you have a certain number, and one final number having some uncertainty. All right, and so you want just the 3 digits. All right, and so the question is this going to remain a 1 or does it go up to a 2? Well, when this is 5 or greater, then it goes up to a 2. When the number next to it that has some uncertainty is less than 5, then you simply get rid of it and leave it as a 1. So make sure you round your numbers correctly. Again, when we are doing multiplication and division, you have on top, nothing here is a 0 on the top one. So every non-zero digit is significant. So this one has 5 significant figures. I may ask which number has uncertainty. It is not the 6, it is not the 8, 9, or 1. It is always the final number, and that number has some uncertainty. Same thing here. You got 4 sig figs. The 9 has some uncertainty. Here you have 3 sig figs. The 8 has some uncertainty. You have all certain numbers plus one final number having some uncertainty. And so when you have a multiplication division problem, it is all about the sig figs and it is the lowest number of sig figs. So 5, 4, 3. So this one needs to go to 3 sig figs. So the question is, does this 4 remain a 4 or does it go to a 5? Since this is less than 5, you simply get rid of those and it remains a 4. All right, so this one is a subtraction problem. All right, and so you don't say 3 sig figs and 3 sig figs. So you must know your two rules. You got 3 decimal places, you got 2 decimal places, and the rule is the least number of decimal places. So we have to have 2 decimal places. And so we are at the 3 here. That is the second decimal. So the question is, do we leave it as a 3 or does it go to a 4? Since it's a 7, which is greater than 5, it goes to the 4. So negative 1.14. All right, so make sure you know the two rules, one for addition, subtraction, and one for multiplication, division. All right, so here you have 3 decimal places. We're doing a subtraction. 3 decimal places, doing a subtraction. It's not sig figs, although that is also 3 sig figs and 3 sig figs. But if you do it that way, you would get the wrong answer because it is a subtraction. We want 3 decimal places, and there is the third decimal place. And since there's nothing but zeros there, it is 0.035. So note, you could say that I had 3 sig figs and 3 sig figs, and I ended with 2 sig figs. That is a correct answer. that is what happened, but that is not how you get to the answer. I have 3 decimals, subtract 3 decimals, my answer has to be to 3 decimals. All right, when you have multiple things, all right, you have to follow your order of operations. So parentheses first, you do that subtraction and follow the rule. All right, and so that was the 0.035. That's the one we just did. All right, so you have your 0.035. Now that, again, is 2 sig figs because that's important now that we're doing a multiplication. You have 2 sig figs, you have 4 sig figs. The initial was 3 decimal places and 3 decimal places because we did the subtraction first. You get that answer. Now that answer has 2 sig figs multiplied by 4 sig figs, and you give your answer to 2 sig figs. And since the number next to it is less than 5, you simply leave it as a 3.2. All right, so you want intermediate answers. You have to know what the answer is to this subtraction. If you put everything in and you're like 4 sig figs, 3 sig figs, 3 sig figs, well, that's wrong. It is not 3 sig figs. Once you do the subtraction, you are down to 2 sig figs. And so your answer is reported 2 sig figs because you're doing next a multiplication. So that would be a good test question, because if you did the wrong rule, if you said, oh, I'm doing subtractions and I have 2 decimals in the first number, 3 and 3, I give 2 decimals, wrong answer. I'm doing a multiplication here, so I have 4 sig figs, 3 sig figs, 3 sig figs, I give 3 sig figs. That's the wrong answer. If you do it incorrect, you will get the incorrect answer. That's the way the test works. Make sure you are doing your parentheses first and seeing that that's 2 sig figs when you multiply it by 4 sig figs. All right, SI units. So there will be some questions, multiple choice questions, may or may not be some questions about SI units. Normally the question is, you will convert this to the SI unit. But if you don't know what the SI unit is, then you're going to have a hard time answering that question. All right, so you will need to know table 1.1. You have to know the SI base units. All right, so a length is in meters. The one that is asked most often, because the one that's missed most often, is the next one, because the SI unit for mass is the kilogram. It is not the gram. So that is the most commonly missed question for SI unit. So if I have milligrams and I say convert it to the SI unit for mass, most people, or a lot of people will put it in grams. That is the wrong answer. It has to be in kilograms. That is the SI unit for mass. Time is seconds, temperature is Kelvin, amount of a substance is a mole. We will get to conversions to mole soon. Electric current, we don't use, I don't think we use that at all this semester, but it's amps. And luminous intensity, we don't use that at all. I haven't seen it in the book, but anyway, that is the SI unit for it. So you can not worry about the last two. But you need to know the length, the mass, the time, and the temperature, the meter, the kilogram, the seconds, and the Kelvin. So those are the 4 that you will, or 5 you need to know. All right, we already went through table 1.2, so you need to have that memorized as well. We're going to use that for conversion factors. I realize centa and milli you're very familiar with. And kilo you're familiar with, and you do it whatever way you do it. Again, if you do it the way that I show, then it works the same for all of those. But I don't care how you work the problem. Make sure that you get the right answer each time and you know what you're doing, and that is fine. All right, so again, sig figs, we went through that. The last digit has some uncertainty. You have certain number, whatever. If you have 3 sig figs, you got 2 certain numbers and one, the last one, that has the uncertainty. And we went through that. We did our conversions. And again, we're not going to have Fahrenheit questions on the test. You may have those on the homework, but they will not be on the test. They will be Celsius Kelvin questions. All right, so again, area was length times length. So the SI unit for length is meters. So length times width, when it's a distance, it's meters. Meters squared. Volume, length times width times height. 3 distances. You have meters cubed. And density is mass over volume. So when you have your mass over your volume, so that is a good question that I like to put on the first test, convert the units of the density of copper into the SI units. So if you do not know the SI unit for mass is the kilogram, well, then you can't get this correct. If you don't know the SI unit for volume is meters cubed, again, you can't get the correct answer. All right, so the one that you are most often asked is density. All right, for the first test, so you have to know that it's mass per volume, and so that gives you a kilogram per meter cubed. All right, so speed is meters per second, acceleration meters per second squared. We will do those later. Right now, we are doing our densities. Force we'll do later, pressure we'll do later, and energy we will do later, but these are very important. So you should know these for the test, for any multiple choice question. SI unit for energy is the joule, SI unit for force is the Newton, SI unit for pressure is Pascal. But that's just a memorized thing. It's not going to be a problem to work out. All right, that one, that one. Our conversions. Oh, I wanted to go back to this one. All right, so on this problem, note that on the test, it may say the same thing, except it won't give two questions. It'll just give one, and that will confuse you. So if you have 573 milligrams, I will say convert that to kilograms. There is no direct conversion from milligrams to kilograms. If you know what that is and you want to write that down and show it, that's fine. All right, the way to do it is to go from milligrams to grams, because you know that conversion, and that's what we did the first time, right here, milligrams to grams, and then you go from grams to kilograms. So many times there are multiple steps to get the answer on the test, not just milligrams to grams and then grams to kilograms. It might be milligrams to kilograms. So you have to know that first we're going to grams and then we're going to kilograms. It may not be a one-step conversion. It may be a two, or maybe a three, or maybe a four-step conversion. Because if you get this question and you say, I don't have the conversion from milligrams to kilograms, I'm like, well, you do, but it's not one thing. It is two things. I may not say that. I will just say there's a way to get there. And that means, well, I'm going to say, yeah, you're right, but there's a way to get there. It's two steps for that process. All right. And so I think we were here. We have finished this one. We may not have. Remember that 54.3 milliliters, that a milliliter and a centimeter cubed are exactly the same. So when you get a milliliter here, you have to know that a centimeter cubed is the same. So you have to know that a milliliter is exactly the same thing as a centimeter cubed. And a centimeter cubed is a cc because that stands for centimeter cubed. And so when you have 54.3 milliliters, you have 54.3 centimeters cubed. So now we have to go from centimeters cubed to meters cubed. So you have to do it 3 times. 54.3 centimeters times centimeters times centimeters. If you miss this, you should write what centimeters cubes mean. It means centimeters times centimeters times centimeters. So we don't want just 1 centimeter to a meter. We have to do it 3 times. And that is 1 times 10 to the minus 2. Not just 1 time, but 3 times. So centimeters, 1 times 10 to the minus 2 meters. 1 times 10 to the minus 2 meters, centimeters. So now you have centimeters and centimeters and centimeters to cancel centimeters and centimeters and centimeters. And now you have meters times meters times meters. And so that is a cubic meter. And so you have 5.43 times 10 to the minus 5 meters times meters times meters, which is meters cubed. All right, so there's always a test question with a cubic something. And that is the most commonly missed problem on the test. So, because most people only do it one time, and they'll say, you have a centimeter cubed and you have a meter cubed, and they will just put 1 times 10 to the minus 2. And of course, that is not correct. You have to do it 3 times and multiply it together 3 times. If you want to say 1 times 10 to the minus 6 centimeters cubed is 1 meter cubed, well, fine. If you know that, great, that's correct. But most people do not know that. And note, correct scientific notation, you'll have one number and then the decimal point. The 54.3 times 10 to the minus 6, that is the correct answer, but it is not in correct scientific notation. So make sure you have your number in correct scientific notation, which means a number between 1 and 9 and a decimal point after that. All right, so here is another. Oh, okay. So note that in this one, they'll say 3 significant figures. On the test, how do I know that this is 3 significant figures? I'm not going to write that that's 3 significant figures. This could actually be a question. 330 carats, how many sig figs? Again, this number is less than 1,000. If it is less than 1,000, the zeros to the right are significant. So this is 3 significant figures. All right, and so note that the next is a conversion factor. So 1 carat equals 200 milligrams. So that is a conversion. So every conversion is an exact number. So on the test, you will get the same problem, except it will not say this is 3 sig figs. From the rules, that number is less than 1,000. Zeros to the right are significant. All right. This is a conversion factor. 1 carat equals 200 milligrams. That is a conversion factor, always exact. And so you have your 300 carats. I'll just put CA for carats. All right. And so here we have 1 carat, and that is 200 milligrams. All right. And so that gets rid of the carats, and we have 200 milligrams, except that wasn't the question. The question was, what is the weight in grams? And so now we have to get rid of milligrams, and we have to get grams. All right, and milli, you have to have memorized 1 times 10 to the minus 3. So you have it memorized as 10 to the minus 3. Anything multiplied by 1 is the same. All right, and so when you push the buttons on your calculator, you get 60.0 grams. So I did that correctly in my head. All right, so you have 3 significant figures here. This is a conversion factor. This is a conversion factor, and that means an infinite number of sig figs. And of course, the lowest number is 3. So assuming that when you multiply that together, you get 60. Note your calculator will just say 60. You have to know that this has to be the 3 sig figs. All right, so to get full credit, you have to have the correct number of sig figs. You have to have the unit labeled. If you answer this question as 60, well, you will get credit for, well, it is 60, but you didn't label it. You don't have the right sig figs. You're not going to get very much credit at all. You'll get some credit because the answer is what? Oh, because I wrote 300. Yes. So it's not 300. 330. Sorry. So that would be 66 if the question was, well, if you do that on your test and you copy this down wrong, you miss very, very little of the question. All right, so if you write down 300 instead of 330, and obviously that's just whatever, you did everything else right, that's what I want to know. Did you do everything correct or not? So if your answer again here is 66, then that's going to lose a lot of points because you don't have the units, you don't have the right sig figs. So sig figs and units are what this question is about. Right. Copying the question down correctly, not worth a lot. However, if this happened to be a multiple choice and 60 was an answer, you'd get 0 credit. So you want to make sure that you go back and check that you didn't type something in wrong or write something in wrong. All right, so, and you don't have to know what a qubit is. So to get these, if you say on the test, I don't know what a qubit is, I'm like, you don't have to know, but it's on the test that you don't have to know. It's going to give you the conversion factor, all right? And so I will say, you don't have to understand what a qubit is. It's going to tell you a qubit is 1.5 feet. It doesn't matter if you know that, it's going to be given to you. All right, so it's reported as 3.0 times 10 to the second qubits by, all right, so 5.0 times 10 to the first qubits. So that is the dimensions. Express the size in units of feet and meters. All right, so another conversion factor that you must have memorized is 2.54 centimeters is equal to 1 inch. And that is a conversion factor. That is an infinite number of sig figs. All right. So if we have our two significant figures and our two significant figures, and we want to express the size in units of feet and meters, all right? So they don't want the area, all right? They just, if you I thought maybe they were going to ask for the area, and I was multiplying those together. That is not the question. They just want you to convert the 3.0 times 10 to the second qubits into feet and meters, all right? So feet, it gives you that 1 qubit is 1.5 feet. And so that is 4.5 times 10 to the second feet. All right, so when you take 1.5, multiply it by 3.0, you get 4.5, and that's times 10 to the second. That's how many feet. In order to get to meters, you're going to have to take it into centimeters. So first, I'm not going to say that you have to memorize 12 inches in a foot. I'm going to assume that everyone knows that there are 12 inches in a foot. And so now we have our answer in inches. That is not 2 sig figs. That is a conversion factor. That is an infinite number of sig figs. All right, so here you have 2 sig figs. Here you have a conversion factor. It gave it to you that a qubit is 1.5 feet. That is an infinite number of sig figs. Here is 2 sig figs. That is a dimension. That is a measured amount. All right, and so now we're in inches, but we don't want to be in inches, so that's why we have that 1 inch is 2.54 centimeters. And now that we have it in centimeters, then we can convert it to feet. So now, meters. So centimeters. So now we have to get rid of centimeters and get meters. C is 1 times 10 to the minus 2. All right, so again, everything on top, you multiply, everything on bottom, you divide. Everything in this problem is on top. I don't think I'm going to be able to do that one in my head fast enough. So, so 4 point, okay, so that's the answer in feet. So the 4.5 times 10 to the second feet, we had that. All right, so they're giving others, but I guess they have those memorized. You have those memorized and use them, great. The number that I'm going to give you, I'm not going to give you any conversion factors for this except for the qubits to feet. You have to know 12 inches is in a foot. You have to know that 2.54 centimeters are in an inch. So if you multiply my numbers on the numerator, you will get 1.4 times 10 to the second. All right, so you can see the way that they do it, and it will give you the same answer. You do not have to memorize that. This, I expect everybody to know that they're 3 feet in a yard. This is given. All right, so the yard to meters, no, you're not going to memorize that. You're going to memorize 2.54 centimeters is equal to 1 inch. And again, this isn't, I expect you know 3 feet in a yard, but that's not the one you would use. You're going to use 12 inches is equal to a foot. And I expect you to know that as well. So everyone should know there's 3 feet in a yard, and everyone should know there's 12 inches in a foot because we live in the United States and that's what we use. All right, so how many sig figs are in each of the following measurements? Again, you have to follow your sig fig rules. So if you have a decimal point, the zeros to the right all are significant. When you have a decimal point, zeros to the right are significant. If you have a decimal point, the leading zeros are not significant. So here you have your 4 sig figs. The error, again, the uncertainty, the number that has some uncertainty or possibly some error in it is always the last digit. Zeros to the left are not significant. So you have your first non-zero digit, that's that one. Zeros to the left, leading zeros, they are not significant. Once you have your decimal point, all zeros to the right are significant. And so that is 6 significant figures. All right, again, the last one is the one that has some uncertainty. Same rule for C. The zeros, the leading zeros, zeros that are to the left of the first non-zero digit. These are not significant. These are not significant. Once you have a decimal point, zeros to the right of the first non-zero digit are significant. So this one is significant. So that is 1, 2, 3, 4 significant figures. All right, again, you have your decimal point, and so zeros to the right are significant. All right, so you have your first non-zero digit, zeros to the left. If I wrote 004, that doesn't mean anything. Zeros to the left of the first non-zero digit are not significant. Zeros to the right are significant. And so this is 4 significant figures. You have your decimal point, and so zeros to the right are significant, 4 significant figures. Here, you do not have a decimal point. And this number is greater than 1,000. 91,000 is greater than 1,000. And so when your number is greater than 1,000, zeros to the right of the first non-zero digit, it does not have a decimal place. These are not significant because the number is greater than 1,000. All right, so this one is 2 significant figures. If I had 100 here, that number is less than 1,000, and so this would be 3 significant figures. All right, so that is the rule for a number that does not have a decimal point. It's a large number, lots of zeros, no decimal places. All right, so if that number is large, meaning greater than 1,000, then it is not significant. Those zeros are not significant. If the number is 1,000 or less, then it is significant. All right, so we're going to go into chapter 2. Find where I put it. Chapter 2. All right, so chapter 2 is going to have a lot of nomenclature in it. All right, so atoms, molecules, and ions. So we talked a little bit about the periodic table. So you have your elements on the periodic table. All right, the smallest part of the element is the atom. All atoms are neutral. All molecules are neutral. If you are not neutral, then you are called an ion. And so atoms, all right, you got molecules, more than one uh, element combining to form a compound. That is then the smallest part of a compound, a molecule. And then ions, something that has a charge. Atoms are neutral, molecules are neutral, ions have a charge. All right, so atomic theory, that's the objectives. All right, we're going to balance equations as well. All right, so a compound, got Dalton's law. All matter is composed of indivisible atoms. This is back in the day, and now we have split atoms. We have the atomic bomb. All right, so back in the day, it was all matter is composed of indivisible atoms. We are now able to split an atom. An atom is an extremely small particle of matter that retains the identity during a chemical reaction. So again, that is a chemical reaction, not a nuclear reaction. An element is a type of matter composed only of one kind of atom. Again, that is not correct either. All right, so Dalton had postulates that were very insightful. Some of them are still true, but some of them, as these two, are not true. So elements, you'll have carbon 12, carbon 13, carbon 14. So there's more than one kind of atom for an element. And of course, we can split the atom as well, but this was back in the day and very insightful. And then his other postulates are a compound is a type of matter composed of atoms of two or more elements chemically combined in fixed proportions. That one, yes, is still true. A chemical reaction involves the rearrangement of the atoms present in the reacting substance to give a new chemical composition. Combinations present in the substance formed by the reaction. Okay, that is, yes, still the definition of a chemical reaction. So he had his postulates, a couple of them not correct and a couple of them correct. All right, the atomic symbol. You'll see, again, periodic table is given on every exam. All right, and so on that exam, you'll have the atomic symbol. So it's going to be a 1 or 2 letter notation. First one is going to be uppercase letter. Any other letters will be lowercase. So if you're getting fancy, do not get fancy with the symbols on the periodic table. The first one must be uppercase, and the second one has to be lowercase. All right, so uppercase for the first one, second one has to be lowercase. So make sure you're not getting fancy with your symbols. That is the way that they have to be. Upper letter, uppercase, and then lowercase for the second letter. All right, many of these symbols come from the, they come from the element's name, but many of these are in Latin. So Na for sodium makes not very much sense. Fe for iron doesn't make much sense. Okay, so many of these symbols will be from the Latin language. All right, so law of multiple proportions. So here we have CO2, which of course is carbon dioxide, and we have CO, which is carbon monoxide. So carbon and oxygen combine in more than one way. So you can have a carbon 1:2 ratio, or you can have a carbon 1:1 ratio with oxygen. All right, so when two elements form more than one compound, so carbon will burn in oxygen, it will form both carbon dioxide and carbon monoxide. The masses of one element in these compounds for a fixed mass of the other element are in small whole number ratios. All right, so here is our carbon. All right, so when you have carbon monoxide, if you take 12 grams of carbon, it will react with 16 grams of oxygen. All right, and when we get the molar masses, carbon's molar mass is 12, oxygen's molar mass is 16, and that is 1 and that is 1. You need 1 mole of each one and a 1:1 mole ratio. All right, when you have carbon dioxide, CO2, you're going to have twice as much oxygen. So the same amount of carbon, 12 grams, and twice as much oxygen, 32 grams. All right, and so you would have twice as much oxygen in CO2 as you would have in a CO. All right, so that is a law of multiple proportions. All right. Which of these depicts CO? All right, so here you have two of the same. So it could be hydrogen, nitrogen, oxygen. Oh, let's call it nitrogen, whatever. So this is a diatomic element. All right, so it's two atoms of the same atom. So here is a monatomic atom. So this is whatever. What do we want to pick? Say helium. Any monatomic element. This one is two different colors, which indicates two different elements. All right, and so this could be, say, SO3, whatever. So it could be anything. It's one element and three of another. This one has three different elements. And so this could be whatever. I'll just make Cl. That's a good example. So let's go with SCLO. Yeah. Anyway, you have two elements and three elements here, three different colors. So here we have two elements, all right, and then this is CO2. So you have two elements, carbon in the middle, and you have your two oxygens. So the only possible model that would show CO2 is the one that has two colors, one color for the C, one thing that is the color for C, and then two that are for the O. All right, so this one has something, one thing, and three others. So I could just have done generic X, Y, 3, and this is X, Y, Z. So it's three different things. All right. All right, so an atom, all atoms are neutral, right? And so when you hear the word atom, it is neutral. That means that you're going to have the same number of pluses as minuses. When you have an ion, that is going to have a charge. All right, so when we look at an atom, we look at the two parts. We have the nucleus, and then we have the electrons that are outside the nucleus. So in the nucleus, all right, you have your protons. And that's why the nucleus is a positive charge. And it also has most of the atom's masses. It also has neutrons. So your nucleus contains your protons and your neutrons. Outside the nucleus is the electrons. All right, and so these are very light. They do not have a very large mass. So a proton is about 1 atomic mass unit. A neutron is about 1 atomic mass unit. And this one is like 0.00055 atomic mass units. So when sig figs and you add them up, let's say we had 10 neutrons, 10 protons, 10 neutrons, and 10 electrons. So you add 10 plus 10 plus 0.005 and you get 20. So sig figs tell you that this is insignificant. And so the mass of this nucleus, or this atom, would be 20 AMU. All right, because when you do the sig figs, the amount of electrons is insignificant. It does not change the mass. Protons have a positive charge. Neutrons are neutral. Electrons have a negative charge. And so to be neutral, you have to have the same number of protons as you have electrons, and that will give you a neutral atom. All right. So all atoms have the same number of protons as electrons. Protons, electrons have to be the same. J.J. Thomson did an experiment, found the electron using a cathode tube ray, and Millikan did the oil drop experiment, found the mass, and Rutherford bombarded gold with alpha particles and found that the nucleus contains most of the mass. All right, so all of that is history and great. All right, I don't usually ask historical questions on a test. So your proton. All right, so we already had that the proton has a mass number of 1 and it has a plus charge. So a proton, you need to know that the mass is 1 and the charge is a plus 1. All right. So a proton is the atomic number. So you're given your periodic table and it's listed 1 to 118. The 1 to 118, that is the atomic number. And the atomic number gets the letter Z. So that is your atomic number. The atomic number is equal to the protons. All right, so it's very easy. How many protons does hydrogen have? Well, its atomic number is 1. Yes, 1 proton. All right, so an element is a substance whose atoms have the same number of protons and thus the same atomic number. All right, so all elements, the atomic number is the number of protons. That is the key there. To get the number of protons, you simply look at the periodic table. The atomic number is the number of protons. All right, so the neutrons also have a mass of 1, but a charge of 0. All right, so when you have your compounds, and I told you that carbon comes in 3 forms. We have carbon 13, we have carbon 12, we have carbon 13, and we have carbon 14. So those are called isotopes. All right. So that means that they have different masses. The 12, the 13, and the 14, that is your mass number, and that has the letter A. So when you say carbon 12, 12 is the mass number. Now, your mass number is simply your protons, which have a mass of 1, plus the neutrons, which has a mass of 1. And if you looked at the periodic table, you would see that carbon's atomic number is 6. So carbon has an atomic number of 6. And therefore, you have 6 protons. You should never miss how many protons does an element have. You simply find it on the periodic table and its atomic number, that's the number of protons. All right, and so when we have carbon 12, we have 6 protons, and now I know that the protons and the neutrons equal 12, and so I know that I have 6 neutrons. Carbon 13, it doesn't matter what the mass number is. If it's carbon, it's 6 protons. If it's carbon, it's 6 protons. In order to have a different mass, you have a different number of neutrons. And so carbon 13 has 7 neutrons. Carbon 14 has 8 neutrons. All right, and so that is your mass number, the protons plus the neutrons. All right, now these are atoms. So carbon 12, carbon 13, carbon 14, that is atoms. Atoms means that it is neutral. And so for all atoms, all neutral atoms, atoms are neutral. You don't have to say neutral with it. You have to know that atoms are neutral. That means that all of these also have 6 electrons, 6 electrons, 6 electrons, because they're all neutral. Number of protons, number of electrons have to be the same. So carbon 12, carbon 13, carbon 14, these are called isotopes. They are atoms whose nuclei have the same atomic number, which means the same number of protons, carbon 666, all right, but different number of neutrons, 6, 7, 8, all right, so that is isotopes. So these are the 3 isotopes of carbon. Carbon 12, carbon 13, and carbon 14. So you have to know what an isotope is, you have to be able to get the number of protons. That's simply the atomic number, and the number of neutrons, because the mass is given. Protons plus neutrons equal the mass. And for all atoms, the number of protons equals the number of electrons. They are all neutral. All right, so then we will write it as a nuclide symbol. So there will be problems on the test. It says give the nuclide symbol for sodium 23. So here is the nuclide symbol for sodium 23. Well, you have to know that Na is sodium. You find it on the periodic table. The atomic number is 11. And so what you write is the mass number on the upper left, and on the lower left, you write the atomic number. All right, so A, remember, is the mass number. This is the protons plus the neutrons. Z is the atomic number. That is the protons. All right, if there was a charge, you would put it here. All right, so if it was the sodium ion, which is a positive ion, then you would have to put the plus at that spot. All right, so all of these are neutral. All right, and so now we know how many protons, neutrons, and electrons we have for all of these. So we see that sodium has 11 protons because that's the atomic number. That is the number of protons. You simply do a quick subtraction, 23 minus 11, and you have 12 neutrons. That's how the mass is now 23, because 11 and 12 equal 23. And so these are all neutral, so we know that the electrons is the same as the protons. All right, so these problems will be on the test. These should be the easiest problems to get right on this test. So lithium, 3 protons. I know that 3 plus 4 is 7. That's how many neutrons we have, because this is your protons plus your neutrons. 3 and 4 equals 7. And since it has no charge, I have 3 electrons. So the protons, I usually will put a plus, indicating that that has a plus charge, and the electrons minus charge. They have to be the same for all atoms that are neutral. And we already did carbon 13. That's 6 protons, that's 7 neutrons, and that's 6 electrons. All right, so these should be very easy questions to get the number of protons, neutrons, and electrons from a nuclide symbol. All right, you will have to write the nuclide symbol for an atom that has 19 protons. So you will be given a periodic table. You will not have to memorize it. So you will see that element 19 is potassium. So the first thing you're doing is going to the periodic table and saying, what element is atomic number 19? So that is potassium. And that number, you have to know, goes here. All right. You see that we have 19 protons. All right. And it says atom. And so now we know we have 19 electrons because all atoms are neutral. All right. But up in the upper right is your mass number. You have to know that that is the number of protons plus neutrons. So you have to add these two together to get 39. And so the nuclide symbol is a 39 and a 19, and then the symbol for atomic number 19, which is potassium. You don't have to memorize atomic number 19 is potassium. You have a periodic table. All right, so atomic mass. The average atomic mass for a naturally occurring element expressed in atomic mass units. So we use AMU very, very shortly. Instead of AMU, we're going to use grams per mole. All right, and so the atomic mass unit or grams per mole can be used. All right, so when you look at the periodic table, the mass is given, and it is all based on a carbon-12 system. And so your carbon-12 is the base for these atomic mass units. It used to be oxygen-16, now it is carbon-12. All right, so an element has 4 naturally occurring isotopes. It's not carbon. Carbon has 3, carbon-12, carbon-13, carbon-14. The mass and the percentages of each isotopes are as follows. All right, so we have an element. All right, if it were carbon, it would be carbon 12, 13, 14. All right, so this is an element. We don't know what the element is, but we do know the element is going to have a much higher molar mass than carbon. It's in the 205, 6 area. All right, so in order to get this answer, what you have to do is you have to multiply these numbers together, except you have to take the percent. All right, you have to get it out of percentage. In order to get a percent, part over whole times 100. We don't want the percent abundance. We need the fractional abundance. All right, so if the fraction is 1/2 or 0.5, the percent is 50%. All right, to go from a fraction to a percent, you multiply by 100. To go from percent to a fraction, you have to divide by 100. And so for all of these, you need to put it into a fractional abundance. So we have to divide by 100. So 0. All right, so we take and we multiply these two numbers together. 0.0148 times 203.973, we get a number. 0.236 times 205.9745, we get a number. 0.226 times 206.9759, we get a number. 0.523 times 207.9766, we get a number, and we simply add them up. We add these four numbers up, and that is the atomic weight of this element. In order to get the name of the element, you look at the periodic table, you match that atomic weight with the symbol, and whether that is the name or the symbol, many times on the test, I will say give the symbol for that element because maybe that's not one that you have to have memorized. All right, so when you do that, when you multiply these two numbers together, again, you put it into fractional abundance, and you multiply these two numbers together. All right, so you had 3 sig figs times 6, and so you give 3 sig figs. So if you rounded it, you would give 3.02. All right, you have 3 sig figs times 7 sig figs, you're going to give 3. And so that would be a 48.6. All right, and then 3 sig figs times 7 sig figs, 3 sig figs, that would be 46.8. All right, and when you had 3 sig figs times 7 sig figs, you give 3 sig figs, and that would be 109. All right, I don't care which way you do it. If you do it the way I have it down below and you get your answer, great. If you do it like they're doing it in the book, they keep all of the numbers together and then they do the sig figs at the end, that's great as well. I don't care which way you do it. The final answer, make sure. So we take 109, we add 48.6, we add 46.8, and we add 3.02, and that's going to give us 18. So, yeah, okay. It doesn't matter in this case because that would be a 207.4. You get 207. So the only correct answer is 207 AMU. Sometimes, again, this is 3 sig figs, so this one has some uncertainty. All right, so if you rounded it and then added it, sometimes you would get 208. Sometimes you might get 206. If you keep all the numbers together and you get 207, if you're that close, I make sure that you didn't do anything wrong. Many times you can do everything right and get a slightly different answer. So then you simply go to the periodic table and you find that the element is lead. And so this element is lead. And we will pick up there next time.